Hi there, welcome to this lecture. We're going to continue talking about aggregations. I had to cut the previous lecture short, so let's continue. If we wanted to, for example, get all of the statistics such as average, min, max, there is a shorthand. Rather than running an average price, a max price, a min price individually like this, we can use something called stats. So instead of the average function here, I could just say stats. Okay, and let's just eliminate all of these other fields here. And I'll call this, instead of average, I'll say stats on price. So it's going to run a statistics on the price field. Let's hit play. And there you go. Notice that for Dodge, it's giving the minimum, maximum, average. For BMW, it's giving the minimum, maximum, average, sum, and so on. So to get a more holistic view of our data, let me get rid of this query so that it applies to the entire set of documents that are within cars. So let's hit play and notice that you get the actual results. We got 3 Chevrolets, 2 BMWs, 2 Fords, and so on. And it's giving the count, min, max, average, sum. Very, very useful. That's the stats property provided by Elasticsearch. So again, understanding this query syntax, this ags field is provided by Elasticsearch. I didn't make this up. The size provided by Elasticsearch, I didn't make this up. The only thing that I define here is this popular cars. And that's it. For here, stats on price. This is the only field that I find. Everything else is part of the Elasticsearch DSL, okay? Now you might be thinking this syntax is a bit confusing, but it's not that bad once you get the hang of it, okay? And there's some terminology to help you better digest this information. So there's something called buckets and metrics. And what we're doing here on this first part is we're creating a bucket, right? We're creating a bucket called popular cars. And it's based on this field, the make, right? The manufacturer, the vehicle manufacturer. And then this is the metric, where we're defining the metric to be stats on price. And then we're specifying the fields that are involved in that. So when you look at this data on the right, you'll see that there we have the Dodge bucket, we have the Chevrolet bucket, we have the BMW bucket, and we have the Ford bucket. Okay, these are buckets based on the make field. So similarly, you can create buckets of date ranges. For example, we have vehicles that were sold on different dates. There's a field called sold on the document that specifies which date the vehicle was sold. So we can create a bucket based on date ranges. So let me do that. I'm going to rename this to, instead of stats on price, I'll just say sold date range, or ranges rather. So this is something that I've made up. In here, I can use the range field that Elasticsearch provides to create range buckets. And then we specify the field that we want to build the range off of. And that's going to be the sold field. And this basically this contains the dates, if you recall from the documents. So after this, we specify the different ranges. And then this is going to be an array field in which we specify the different ranges that we want to bucket our data. So the first one, we can say that from the date 1601-01, the first of the year, to May of 2016. So let's just do 2016-5-18. All right, I'll just pick a random date. I think I have a vehicle that was sold on this date. So that's one range, and it needs to be defined in, we're in an array here. So what are these values? We can't just leave them in like this. They need to be in a JSON object. Everything in JSON should be in these JSON objects, right? So since we have an array, we need to make sure that we put JSON. And then after this, we can specify another range. So let me just copy this to make my life easier. And this is our second range, and I can start this from the range that I provided here, the end date of that previous range. And I'll make this 2017. I don't think we sold any vehicles in 2017. So this should include pretty much all of the vehicles. Okay, so we've got 2 ranges, and they're defined by this from and to. And by the way, this to is non-inclusive. Okay, so that is why I'm repeating this to in the from of the second range. So let's hit play, and these are our aggregations. So it's using some syntax to display the time in a string format. Let me just expand this so that we can understand it better. So these are our different buckets. We first have this bucket, which has the vehicle Dodge, and then it shows the document count, and then it says, you know, these are the sold date ranges. This is a field that I defined, and these are the buckets that have been defined for that field. So the first bucket is, you know, for the 2016 from January 1st all the way up to May 2016, and in this bucket we have 4 vehicles that were sold. Okay, and then in the second bucket from May 18 to 2017, that's the rest of the year, we only sold 1 car. And by the way, what car is this? This is the Dodge. So that same kind of summarization is being taken place for each one of these makes. So for Chevrolet, you know, we sold 3 cars. For the first date range, we didn't sell anything, but for the second date range, second half of the year, we sold all 3 Chevrolets. Okay, and then moving forward, we have the BMW. We sold 1 in the first half of the year and another in the second half of the year. This is basically the string format of the date, and this is a Julian, I believe, format for the date. Not important, as long as you understand that, you know, the from date is this, and the to date is right here. Okay, so I think now is a good time to give you a quiz. And, you know, it might take you a long time to figure this out, but that's okay. It's part of the package. Okay, that's how you learn. Could you figure out what is the average price of the vehicle sold during the different date ranges? All right, so we have this range. We have these 2 ranges. So for each range, I'd like to see what is the average price of the vehicle that was sold within that range. So take a moment to, or take as long as you need to, pause the video to try that out on your own, and then you can resume to watch my solution. Okay, welcome back. Hopefully that didn't kill you. I know it may have been a challenging exercise, but hopefully it provided you enough practice. So we've got this range right here. Inside of this guy, I can define another ag, right? Just like we did here. So inside of popular cars, right, we defined this ag. So inside of this sold date ranges, right, I can define another ags. So put a comma here and then put ags, and then I want the average price of the vehicle, right? So I can define the field, we'll just call it average price. And then here's where we define the property that we're going to use, and this is provided by Elastic, the AVG. And in here we define the field, and that's going to be price. All right, so this should answer the question. Let's hit play, and let's minimize this so we can get a good look at the data. So during this particular bucket, this range, the first half of the year, we sold 4 Dodge vehicles. Okay, the average price of the vehicle sold were $19,125. For the second half of the year, we sold only 1, and that vehicle's price was $18,000. Okay, it's only 1, so the average is going to be the same. Moving on to the Chevrolet, the first half of the year, we sold no vehicles, no Chevrolets. So the average price here is just, you know, it's null. But for the second half of the year, the second range, we sold 3 Chevrolets, and the average price for the vehicle sold was $20,333. Moving forward, we got the BMW. We sold 1 BMW in the first half of the year and 1 BMW in the second half of the year. And, you know, the average is going to be the same as the vehicle price there, since it's just 1 vehicle. And then for Ford, you know, you get the idea. All right, so let me just quickly walk you through this again. We've got the first bucket called popular cars, okay? And then within this bucket, we've got the another bucket called sold date ranges. All right, this is a nested bucket within the popular cars bucket. And then within this range bucket, we have the metric for the average price. All right, and this is the metric that we are using, the average function, which is provided by Elastic. So we've got a bucket within a bucket, and the inner bucket has a metric that's applied to it. So that doesn't mean that that metric is only applicable to the inner bucket. It's also going to be within the scope of the outer bucket, right? So for a particular type of vehicle, for example, Dodge, the price is being tabulated for all the Dodges that are within the given range, or all the Toyotas that are within the given range, okay? Let's change the first bucket to something called, car conditions, because we have different vehicle conditions. Some are good, some are brand new, some are old. So car conditions and terms, and I'm going to use the condition field. And again, this is a text field that was automatically defined by Elastic. When we index those documents, we didn't specifically define the field to be a keyword. So if we don't use the dot keyword, it's not going to be able to run the aggregation on it by default. So we need to use dot keyword for bucketing over textual data like this. So let me just get rid of this ag here. So let's hit play, and this is just going to give us the different vehicle conditions. So we've got 6 good vehicles, we've got 6 new vehicles, we've got 4 okay vehicles. If I want to get the average price for each one of these conditions, why don't you take a moment to try that out on your own? Pause the video, try that out, and then you can resume to watch my solution. All right, welcome back. All we need to do is inside of this car's conditions bucket, we just put another ags. And then we define our own field name. We'll call it average price. And in here, we use the AVG property provided by Elasticsearch. And then we put the field that contains the price. All right, so let's hit play. And there we go. We got 6 good vehicles. The average price is $19,000. We've got 6 new vehicles. The average price is $36,333. And we've got 4 okay vehicles. The average price is $11,375. Okay. Now try to envision what would happen if I was to add another bucket here, or another breakdown. Like if I was to add, the make of the vehicle and define the field make. So with this query, try to envision what this data will look like. And then I'll hit the play button so that you can see. Try to envision in your head how the data will look. So let's hit play. And here we are. So we've got the car conditions bucket, within which we've got the good condition, 6 cars. The average price is $19,000. And then we're getting a breakdown for each one of those 6 cars. What is their make, all right? So we've got 2 Dodge that are in good condition. We've got 2 Toyotas that are in good condition. We've got 1 BMW that is in good condition. We've got 1 Chevrolet that is in good condition. Okay, so hopefully this is starting to make some sense. Notice the power of aggregations in Elasticsearch. We could use this nested buckets and get some very powerful insight into our data. Now for each one of these manufacturers, Dodge, Toyota, BMW, I'd like to get the minimum price and the maximum price. How would we do that? Try that out on your own, and then you can resume to watch my solution. Okay, welcome back. So I wanted you to get the minimum price and the maximum price for each one of these manufacturers, the Dodge, Toyota, for each condition bucket. Right after the make, right after this condition, we just put a comma. We're still in the make area, and we put another ags like that. And in here, I'm just going to define a field called min price, and we'll put the condition we'll use the min field provided by Elastic. We'll define the fields price, and we're going to do basically the same thing for the second, and that's going to be max, and change this to max. All right. Let me expand this so you can clearly see what's going on here. So within this make bucket, we have another ags. So we're getting the breakdown of the minimum price as well as the maximum price for each one of the vehicles that are falling within each one of these condition buckets, good, new, and okay. So let's hit play. And here we are. So for each car condition, we have the different makes. We've got 2 Dodge that are good. We've got 2 Toyotas that are good. But we also get the max price for the Dodge as well as the min price for the Dodge that are considered good. And then Toyota, we get the 2 max price for the Toyota that is considered good, and the minimum price for the Toyota that is considered good. All right, and then keep going down. This is the second large bucket for the new. This is the new bucket, and in here it's a similar breakdown. For each one of the manufacturers, Ford, we've got 2 new vehicles. The maximum price is $30,000. The minimum price is $25,000. For the BMW bucket, we've got the max price $80,000 and the minimum price $80,000, and that's, this is all in the new bucket. So notice how powerful this query language is. And like I said, I can add a query up here, and whatever query that I provide up here, this Aggs is going to run in that scope, right? So Elasticsearch is going to fetch the documents based on that query first, and then run these Aggs on the results of the query, which is called aggregation scoping. And all of these aggregations can be done in real time. If you have 1 billion records in a relational database table, and you have 1 billion records in Elasticsearch, these aggregations are going to work much faster compared to the relational database, trust me. So Elasticsearch is kind of a new kid on the block when it comes to big data, but boy, is it big. It's very, very powerful.